question says differentiate the following expressions with respect to x, simplify your answer. All right, so let's take a look at this one. What we're going to do, we're going to rewrite this. So I'm going to put it on this side. So what we have here is y is equal to sine 4x. So y is equal to the sine 4x plus 3. And I'm going to take this x to the fourth as a denominator. I'm going to represent it times x to the minus 4. So I'm going to put it in a power form so I'm able to go ahead that way. So we're going to do dy dx. So dy dx, what's the differential of a sine? That's going to be cosine, right? So we're talking about sine, we're going to get cos 4x and 4 cos 4x. And for this part, the second part here, negative 4 times 3, that's negative 12. And then we have 12x, and then minus 1 from that to the minus 5. And if we put this back in the format, we're going to have 4 cos 4x, and then this is going to be, we're going to have minus 12 over x to the fifth, putting it back in the format that we got it, basically. And that is the differential of that there. Now, the B part says determine the coordinates of the stationary points of the curve. So we have this. So basically, what we want to understand is if we're going to find the stationary point, whenever you take the derivative, that is your gradient function. So at stationary point, our derivative, in this case, it will be dy dx must be equal to 0. And that is our aim. We're going to go along that road. So what we're going to do first is to differentiate this. So dy dx. So basically, there is 3 times a third. So we have 3 1/3 x squared, because we're going to subtract 1 from that. And then we're going to have, we have minus 5, 2, and then 2 times that times 2. Okay, and then we have x to the 1 because we're going to subtract 1 from that power, plus the differential of 4x is just going to be 4, and the differential of a constant is definitely 0. All right, so there it is that we have that. What we're going to do now is just to go through and to simplify as we go. All right, so in simplification, this would have canceled that. So dy dx is going to equal to x squared. This 2 cancel. This is minus 5x plus 4. So it's going to be x squared minus 5x plus 4. This is our dy dx. But at stationary point, we were saying that dy dx must be equal to 0. So here it is. We're going to say x squared minus 5x plus 4 is equal to 0. And from here, we could quickly try to solve this to find our x values. Being that we could employ factorization here, x squared, we have x. And we're talking about minus 4 and a minus 1, right? So a minus 4 and a minus 1. And then at this stage, we can find our x values because it's either, could put it up there. So it's either, for the first one, it's either x minus 4 is equal to 0. And if we solve this by adding 4 to both sides, then x is equal to 4. That's one of the solution. Or x minus 1 is equal to 0. And if we should add 1 to both sides, x is equal to 1. So we're looking at that, right? So those are the 2 x values that we have at this stationary point. Now, in order to get the coordinates that they want, we're going to substitute in this. So basically, remember, y is equal to, so I'm going to find that, I'm going to find the y when x is equal to 1. So when x is equal to 1, it's going to be 1/3. So I'm going back to the original x to the third, but x is 1 to the third minus 5 over 2 x squared plus 4 times 1 minus a half. So basically what we're doing there, we're substituting the values for x that we have at the stationary point in the original to find the y value, right? So when you work this out, you're going to work this out. This is going to give us 1/3 right here. This is going to give us minus 5/2. This is going to give us 4 minus that. This is actually 3.5. All right, understand? 4 minus a half, 3.5. And then when you put all of this together, we are getting some 1 and 1/3. We are getting 4/3 right here, right? When you work out that fraction, you're getting 4/3. So what that is saying is that one of the stationary point is 1 and 4/3. So that's one of the stationary point. To find the second stationary point, we're going to input 4. So x is 4. So it's going to be 4 raised to the third minus 5/2, 4 square plus 4 times 4. Give me a second. All right, so we have 4 times 4 minus a half. We're simply substituting. What are we looking at? This is 64/3 right here, all right? 64/3, and this is 16, this is 80, this is about 40, all right? And this is 4, 4, 16, 16 times 5, that's negative 80, this is 40 right here, and this is 16 minus a half. So this is like plus 15.5 right there. When we put everything together, what we're actually getting is negative 19 over 6. So what we're looking at here, so this is our y, just like this. We're looking at the point is going to be 4 with negative 19 over 6. And these are the stationary points. All right, nature of the stationary point. So let us go back for our 2 stationary points. One of our stationary point is we have 1 with 4/3, right? So that's one of our stationary points. Actually, x squared minus 5x and a plus 4. So if we're going to take the second derivative, we're going to have d squared y over d x squared. So 2 times x, we're going to go again, and negative 5x is going to be negative 5. This is our double derivative. What we're going to do is to substitute the x values here to see what we get, right? So let us substitute our x value here. So 2 times 1 for our x value here. And then what are we looking at? We're looking at 2 minus 5. This is a negative 3. The key thing here is that this is negative, right? And if your double derivative, when you substitute your x values, which is the x value at the stationary point in the double derivative, if it is negative, that means that this point here is a maximum, right? So this is a maximum right here. So we have a maximum point there. Now we're going to do it again, but we're going to do the other point, right? So what was the other point? We'll make sure that we got that. All right, so the second point that we had, right, was actually 4 with negative 19 over 6. That's the second point. Now our double derivative, which is d square y over dx square, is actually 2x minus 5. We're going to substitute 4. That's the x value. So 2 times 4 minus 5. This is 8 minus 5. This is positive 3. So because this is positive, then we actually have a minimum point here. So this is a minimum point. So that is all we were expecting you to evaluate to tell what's going on there. Let's go for the second one. Second question says, it's a rate of change question. It says the length of the edge of a cube is increasing at a rate. All right. Whenever we're dealing with rate, it's always with time. So it's going at a rate of 0.5. So the length is going at a rate of 0.25 centimeters per second, right? Calculate the rate of change of the volume of the cube at an instant when the length is it. Normally what you do is to write down what you have, right? So in terms of what we have, we got this, which is, as it says, the length All right, the length is x right here because the side's x. So basically what we got was dx dt, and that was 0.25 meters, all right, per second. All right, so meters per second. Let me just write how they have it, meters per second. So we got that. What it is that they want is what we want to know. They want us to tell the volume, the rate of change of the volume. In other words, our intention is to find dv dt, right? So we want to find dv dt. That's what we want to find. All right, so we have what we have. This is what we want to find. And we want to find it when x is equal to 8, right? Now, normally what we do is we write down what we want to find, like dv dt. So dv/dt can be found by doing what? All right. You can start with your dv dx times dx dt. So you could see here, if we should multiply this idea, we'll get dv dt because this would cancel out naturally and you would have been left with dv over dt. That's the concept here. So what we're saying here is that we have dx dt already, so we need dv dx, but we can get that from the formula because we're dealing with a cube, right? We're dealing with a cube. How do we find the volume of a cube? So the volume, this is x times x times x. So the volume of the cube is actually x to the third. And then we're going to utilize that. So let us look at this. The volume of the cube can be dealt with by using v, which is equal to x to the third. Therefore, dv dx is going to equal to 3x squared, right? So we're taking the derivative of that. So now that we have that, we could go back now and say, okay, at this moment, we can say dv dt is going to equal to dv dx, which is this, which is 3x squared, times dv dx dt, which is this. And we want to multiply that by 0.25. But remember now, we're doing it when x is equal to what? When x is equal to 8. So basically, 3 times 8 square, and you're multiplying that by 0.25, 64, 192, 64, 64 times 3, 192, divide that by 4, we're getting about 48. Context, 48 centimeter cube per second, because it is actually the rate of change of the volume. The moment we say rate of change of volume, it's volume with time, right? So that's 48 cm cube right there. So that one is set. Let's see what we have for the next question, right? Let's see what we got for the next question coming up. All right, so we're dealing with integration here. Let me blow this up a little bigger. So we want to take the integral of the square root of 2x plus 1 dx. I'm going to rewrite this. So what we're really taking is the integral of 2x plus 1, and the square root can be written as a half power dx, right? So we want to work with that. So what we want to do is to integrate this. If I'm going to integrate this, what I'm going to actually have is we could add 1 to the power. So this is a half plus 1, that's 1.5. So this is the same thing here. We're adding 1 to the power. So it's going to be 3 over 2 for 1.5. And then we're dividing by that 3 over 2, right? But remember now, this part here, this 2x will be under here as a division right there, right? So we're going to figure out what goes on underneath there. And all of this plus our constant c. Now we could go again at the denominator. These would have canceled, leaving 3. So definitely there's a 3 under there. So what we have is 2x plus 1. And all of this is raised to the 3 over 2 plus c. So that is basically it. And if we want to put it back in this format, then it's basically having the square root of 2x plus 1, and this is raised to the third power, and all of this is over 3 right here, and then we add our c. That is the integral for that. So this is a nice 3 marks right there. All right, let's jump into getting into those sine and cosines, right? So we want to take the integral of sine 2x plus 5 cos x dx. So we could deal with these in parts, as you could see, right? So the integral of the positive sign, because when you leave from cosine, it's negative sign. So if this is positive, that means this was a negative cosine, right? And then because this is a 2, that means it's a half here already. So what we have is a half cos 2x. So we start off with that half. So it's negative half cos 2x. And for this, the constant is already here. That's not going to change. And this is coming from sine x. And then it's plus c, right? This is well simplified. This can't go any further. This is done. All right. Uh, we're good right there. Let's go to the other question. So this is the one that I skipped to by mistake. So we have figure one. Figure one right now actually shows the region enclosed between the x-axis, the y-axis, the curve y is equal to x squared plus 3, and the line where x is equal to 3. All right, so what we're going to do here is we want to find the region bounded, which is that shaded region right here. So if you look basically, the limits that we have 0 to 3. All right, so these are going to be our limits. We're moving from 0 to 3, and we want to find all of this area. Integration deals with area. So what we're going to do is to take the integral of this curve from 0 to 3. All right, so basically, so remember now, it is actually x squared plus, we did x squared plus 2. All right, so the area can be found by taking the integral from 0 to 3 of x squared plus 2 dx. All right. So basically, what we're doing is we're going to integrate this. So it's going to be x, add 1 to the power, divide by the new power. Integral of 2 is going to be 2x, right? So that's the integral. And where we're taking it from, we're taking it from 0 to 3. Those are our limits there. So all we're going to do now is to substitute quickly to get that value. We're going to substitute the upper limit first. So what we have in here is that we're dealing with, all right, we're dealing with 3 raised to the third over 3 and plus 2 times 3. So that's that first part. And we're going to subtract 0 raised to the third over 3 minus 2 times 0. So that's that. Let us keep working. 9 divided by 3 is, no, 27 divided by 3 is 9 plus 6. And in here, this is all 0, so minus 0. We're looking at 15 square units because it's area that we're dealing with. All right, so basically we're just integrating there and understanding the limits that we have. Not a bad question. All right, for this one, it says figure 2 shows the shaded region enclosed between the x and the y axis, and the curve y is equal to 4 minus x squared. All right, so basically what's going to happen is that if the region is rotated about the x-axis, so we're going to rotate this about the x-axis one complete revolution, calculate the volume. So we're going to take this, it's going to go around the x-axis, and it's going to create some solid. When it goes around there, we're going to create some solid that looks like something like this, right? So how do we do this? Basically, there's a formula that we could use. There's a formula for volume, and it says that volume is equal to pi, it's actually pi y squared. We're taking the integral, right, from a to b pi y squared dx. So basically, y is going to be our function right here. That's like our radius. That's like the radius that's changing at different places. That's what we're doing. And so what we're going to have to do here is just set up this, find y squared, which is our function there. So we want to square that, and then we just put it in and then integrate from 0 to 2, because that would be our limits here that we have here from a to b. Let us deal with y squared, right? So y squared is simply 4 minus x squared, and we want to square that. So easily we could square the first term, that's 16, multiply 4 times negative x squared, double, so that's going to give us negative 8 with x squared. And then you want to square, if you square negative x squared, you get positive x to the fourth. So that is actually what y squared is. So we're going to utilize this in the formula for volume, because volume can be found by taking this. So it's going to be pi, and we're moving from 0 to 2 because we're moving from here to here. Those are our limits, 0 to 2. And y squared is 16 minus 8x squared plus x to the fourth and dx. All right, so that's what we're actually doing. So we're just going to integrate and we're going to work. So let us integrate this. We're going to keep our pi outside, right? So what we're going to actually have here is the integral of 16 will give us a 16x. The integral of this will give us 8x to the third divided by 3 plus x to the fifth divided by 5, right? So this is this, and we're moving from 0 to 2, all right? All right, let us see what else do we do now. We're going to substitute now so that it could keep that pi outside, right? And then in that, we're going to have 16 times 2 minus 8 third over 3 plus 2 raised to the 5 over 5. And then that would have been that part. And then we're going to subtract, put a round bracket here. This is a small bracket, right? And then we're going to subtract now a 16, but this is 0, all right, times 0, right? 16 times 0. And then we have minus 8, 0 to the third over 3 plus 0 to the fifth over 5. And you close this and you close up that one, okay? All right, so basically this is what we have here. And if we keep going, what are the numbers that we're getting out? We'll have pi here. We have 32. Okay, let me just see if I could quickly work these out. Let me see what we have. All right, so we have, let's take one more step here, 32 right here. This is going to give me 8. This is minus 8,864 over 3, right? This is going to give me 32 over 5, right? 32 over 5 for that part. And all of this in the back is a 0, so we have a minus 0. We're good. That is 0. So all we have to do is just to put this together, 32. This is going to land us some 5. Right? So this is what we have, 256 pi over 15 and square, and we're good right there, cube. And that's that. Let's see what else we have here. All right, so in this probability question, that's where we are almost coming down. All right, so it says here, what we're doing. So we have the probability of A, which is 0.8, probability of B, 0.5, P intersect A union, my bad, A union B is 0.9. We want to calculate the probability of B, but given A. All right, what we want to do with this is that whenever we get this conditional probability, we need the intersection, right? Because the formula, if we're going to find the probability of B given A, the formula for it is that we need to know the probability of B intersect A, B intersect A, my bad, B intersect A over the probability of A. This is the formula that we use. So we need the intersection. But remember this formula that the probability of B intersect A is equal to the probability of A plus the probability of B, and we're going to minus the probability of A union B. So in this case, we're talking about 0.8 plus 0.5, and minus in the union is 0.9, 0.13 minus 0.9, that's 0.4. Okay, so this is 0.4. All right. So basically now we could go back and just do what we gotta do. So we want to find the probability of B given A, and this is equal to the probability of A intersect B over the probability of A. And in this case, this is 0.4 over A. What is A? A is 0.8. All right, so you work it out. That looks like it's, all right, so we'll simply get half for that one. This looks like it's 0.5 for that one, for 5 marks. All right, so there it is. So we have that done. All right, let's see what the other question is about. So the other question says, okay, has the even ones. All right, good. Die. The dice are rolled simultaneously and the sums are recorded here. All right, so they're adding these up. Complete the table, complete the possible space um, table below by inserting the sum of the two dice roll. And so on the first, the sum, and the last sum has been already inserted. All right, so they're putting the first and the last. So you could see 1 plus 2 gives us 3, 11 plus 12 gives you 23. So you could just add. At the intersection, you're adding. So 3 meeting 2, that's going to give us 5. All right, so this is 5. And normally, when I see a pattern, I go 7. So it's 5, 7, 9, 11, 13. All right, you keep going. You'll see a pattern. 1 and 4, that's 5. 1 and 5, that's 1 and 6, that's 7. Okay, so it's 3, 5, 7, 9, 11, 13. Keep going. 3 and 4, 7, 3 and 6, 9. Okay, so it's 3, 5, 9, 11, 13, 15. You could see going down that pattern. You've seen that 17, 19, 21. We're seeing it 9. So you're seeing it 9, 11, 13, 15, 17, 19, 21. 19, we were seeing that 17, 15, 13, 11, 13, 15. So you just add them up, 17, 15. All right, so you fill out that and you make sure that you're not making any error as you go along. So it's just sum you're adding up, all right? And you're good after that. So we do that, we would have gotten 3 marks to complete the table. All right. Now let's see what they want. This says, say the probability that the sum of the scores from throwing the dice at the eye is prime. Probability that it is prime, say you want all the prime numbers. Let's see if we can identify how many prime numbers we got here, all right? So probability that it is prime. Prime. Well, I guess you can take out what are not prime, depending on how you want to do it. These are not prime, okay? These are not prime. That's not prime. Everything else is prime. What else? 15 is not prime either. 21 is not prime either. 3 is prime, 5 is prime, 7 is prime, 11 is prime, 13 is prime, 17, 19. So basically out of 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Oh, 36. So it's a possible 36. How many we taking out of it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 from the 36, that's 25. So that means 25 would be prime because everything is prime except those green lines. So it's 25 prime numbers we're seeing out of 36. It's that straightforward. Even. All right, let's look. Is there any even number? Did we see any? No, there is not one even number in our table. So as you could see, there's a 0. Even number 0 over 36, which is 0. All right. So that's kind of straightforward and simple. All right. Let's get it on. Right. Let's go to the next one. So with this time, if it says calculate the interquartile range of the data set represented here. All right, so we want to find the interquartile range of the stem and leaf. All right, so this is like 30, 31, 33, 33, 42, 44, 45, 51, 56, and so on. So we could do a number of things with this. We can do a number of things with this. All right. So what's the first question? Hold on. Did I see the question here? Calculate the interquartile range. All right. Interquartile range can be done by doing Q3 minus Q1. So these are our quartiles. How many do we have? We have, did they say how many? We don't know. We could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we have 20. So 20. So if it is 20, that means it's even number. So 20, my 10th and 11th term will be in the middle. Okay, so I just count 10 and 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is in the middle. 11. These two are in the middle right here, right? So these two are in my middle. So what I'm going to do is to pick them up. All right. So if I pick these up, I'm talking about my middle. This is my Q. This is my middle right here. This is my Q2 right here. So let's quickly just find that. That's my median. So my middle is right here. So there are a number of things I can do. So this will help me. 67 is in my middle, right? Because this is 50, my bad. 57, this is where my middle is. So I could go half of this because it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I have 10, that means 5 and 6 will be in the middle. 5 and 6. So this would be my Q1 now. So going for my Q1 here, it's 1, 2, 3, 4, 5, 6. These two are in my middle right here for my Q1. So my Q1 will be 42, 40. So it's going to be 42 plus 44 divided by 2, and I'm going to get 43. So Q1 is 43. I'm going for my interquartile range, right, which is this formula that we're using right here. So I already have 43. And then I could do the same thing here up top. Because it's 10, I'm going for 5th and 6th. So it's going to be 1, 2, 3, 4, 5, 6, these two right here, right? So this is going to be 67. So Q3 is 67 plus 67 divided by 2. And this is 67. So this is 67. So basically, we're saying 67 minus 43 is 24. Okay, so my interquartile range is 24. All right, so we have 24 for my interquartile range right there and about. All right, so we're good. Remember, there are diverse ways you could do this. The moment you can identify where your center is, then you're able to pick up your quartiles from that and you could move on, right? Now, the second question is saying that, hey, the D part here says figure 3 shows a box. It says it shows a box and Wishka plot, and then which represent a set of numerical data. All right, no problem. It says state the median of the data set. The median, so we could just quickly look. This is my, this is Q1, this is always Q2, and this is always Q3. So this is at 20. This, not really on a number, but we could come up with where it is, basically. All right, so you could see where the numbers fall. This is 10. This is at 20. This is somewhere between 25 to 20, 30. We probably could go 27 or 28. This is about 54. This is about 74 as well. So we could look. So when they say state the median is Q2. So my median, I'll take about 28, right? For my median right there. All right, so I'll grab about 28 for the median. It's right here, it's Q2, right? Now it says determine the range. The range is to take the highest, in this case, it's about 74. And I'm going to subtract the lowest, which is 10. 74 minus 10, that's about 64. So my range is 64. We're talking about having your max and you're subtracting your min, and it's going to give you your range right there. Describe the shape of the data. Whenever we're describing the shape, you want to observe your 3 quartiles, and you could see that here is smaller, right? Here, so it's not split evenly, so it is skewed. It is skewed, so look at the blue, look at the red. You could see the difference here. right? So there's a huge skewing going on. So it's skewed to the lower end, so it is actually positively skewed as we speak. So let's take a look. It says describe. I'll say the data set is positively skewed. It is positively skewed. And the definite reason is that if you take Q3 and you minus Q2 right now, it's bigger. It's not equal. It's bigger than if you take your Q2 and take the Q1 from it. Okay. In other words, then you could see the blue and the red here. This is smaller than this piece. So it is skewed like like that, right? Like this. So this is what we have. Like, you know, and like this is the media and that's the small. We're seeing that sort of thing. So that's it. So it is positively skewed. Um, oh, this table. Okay. Calculate the word. Okay, I think this is variance. Calculate the variance. All right, so if we're going to calculate the variance, what we're looking at is variance has to do with S square and stuff like that. So the variance, all right, let's get into it. All right, let's look. I think the numbers are okay. All right, calculate the variance by squaring that. All right. Also, there's a formula that we use to find standard deviation too. All right. So let's get into it. So in order to find the variance, what we're going to have to do is we're going to have to find the mean, and then we have mean minus x minus. So there are a lot of things that we're going to have to set up leading to it. So basically, let's find the mean, okay? So the mean is to take of these values that we have. We're going to add these values. So we want to find our mean, which is what we call our x bar. So it's 135 plus 144 plus 137 plus 146, 153 people. All right, so we're adding 153. Okay, divide this by 5. Okay, I'm getting that my mean, my X bar is about 143 overall. All right, so in leading to it, what we're gonna have to do, we're gonna have to take our X minus our X bar, and it's gonna be squared. We're gonna need that, right? Because we're going towards the variance. So our X values are what we got from the table. The height, these are our X. So basically we're saying 135, all right? Take away 143, then it's gonna be whatever we get, right? Whatever we get, we take them away and we square them. So this is 8 squared 64. And it doesn't matter if it is negative because when you square it, it's positive. 144 minus 143, that's going to give 1. When we square that, we get 1. 137 minus 143, that's going to be about 6. That's look like about 636. 146 minus 143, this is about 9 when it is squared. This is 153 minus 140. This is 10, 10, 10. This is 100. We need to total that. All right. If you add up that, so that's 100 plus 9 plus 36 plus 1 plus 64. I'm getting 210. This is 210. All right. All right, so we have 210 there. All right, so that's the sum. What we just got here is the sum of our x minus our x bar square. That gives us 210, right? So we need this as we go forward. So here is the deal. The deal is that standard deviation, all right? Standard deviation is equal to the square root of the sum of this, which is what we have already, right? All over n minus 1. Normally it's n, but because we have a sample, then we have to employ n minus 1. What it is that we have, all right? Now remember that the variance is s squared. So that means if you're going to square this, the square root is gone. So basically it's just going to be the sum, which is 210 divided by 4, and this is going to give us 52.5.